Okay, welcome back, AP Scholars. We are going to continue our exciting adventure about inheritance and polymorphism by talking about making variables that are of the type of the superclass, but instantiating subclass objects into them. What am I talking about? This is madness. Hey, maybe I should open up BlueJ. Let's get Bluege. The Bluege opened up, and maybe we could type in some code to explain what's happening. But basically, what if we have a person type variable? Whoops, we got hangman. Whatever. Just make a new. Oh no! Did I want to make a new project? I don't. I just wanted a new class, just somewhere I can type stuff in. And I got to give it a name. Example. So we have like 400 example.javas out there. Sure, we'll just throw this together real fast. Could have done this off camera. Sorry, folks. Sorry. I apologize so much, but it's okay. Public static void main string array args, and then let's do some programming. So we talked about there being this hierarchy of classes, right? We have the person class, we have the student class, we have the undergrad student class, a bunch of different classes. So it turns out that if you make a person variable, so let's say person, my person, that's good. You can do that. You can instantiate a person inside of this. So I can say my person equals new person. I don't know what the constructor is. I don't think we even defined it. Or maybe we did. But I'll just pretend that's the constructor for it. But also, you could instantiate any subclass of person. So I could instantiate a new student inside of my person. I could instantiate a grad student or an undergrad. I think it's just called undergrad. I forget what the capulation is. But regardless, you can even put an employee, although we didn't actually define that one yet. Any subclass of person, you can instantiate an object into a variable of that superclass of the person superclass. So why can you do that? And why would you want to do that? So first of all, it makes sense to do that because maybe you need a variable that's just the most generic variable. It's just keep track of any person. And you want to be able to put any kind of person in there. And that works. According to Java, that's totally fine because students are persons. And grad students are persons. And employees are persons. And undergrads are persons. They're all persons. So it makes sense that they could occupy a person variable. And maybe you need a generic variable. This could be an argument that just takes any person, and it's going to process its taxes or something like that. So you need to have kind of a generic variable that's of the type that's a superclass, so it can accept any kind of person and store any kind of person. So that's fantastic that you can do that. You can't do it the other way around, though. So, for example, if you made a student variable, then you cannot instantiate a person inside. Maybe I'll make this my student. And you cannot say this. My student equals new person. That doesn't work so well. And you might wonder, why not? Students are people. Why can't I do that? The thing is, not all persons are students. There are persons that are not students. So the type has to be of the same level as the object or lower. So if I have a student variable here, then I can put a student in it. I could put an undergrad student, the subclass. I can put a grad student in there, the subclass. But I cannot put an object of its superclass into this variable. That's just not allowed. You can't do that. And if you think about it hard enough, it does make sense because, I got this thing that's a student. I've clearly declared this is the class of this type of object, and I'm putting a person in there. But wait, this person might not be a student. I mean, in fact, it is not a student. It is a generic person. It's not a student. It shouldn't go into this variable. The other way around makes sense, though, because students all are persons, but not all persons are students. So there is an important direction to go, and it's fairly straightforward to understand, either through metaphor and just kind of understanding the meaning of those words, or just kind of looking at the extends keyword. So if I had a variable of type grad student, then anything that extends grad student, or so I guess that says undergrad, doesn't it? So if I have a variable that's of type undergrad, undergrad, my undergrad, then I can instantiate undergrad objects in there, and anything that extends undergrad, and anything that extends undergrad, and so on. That's where it is. But not superclasses. I can't go up the chain and look at its superclass and instantiate those things. So that's the story. And the slideshow I have here goes on to further sort of explain that. If I zip ahead, basically I kind of explain that here in the slideshow. And then I give a little quiz for you to solve. Says which of these will result in an error. And there's actually two of them. And we did this in class, so I won't spend too much time. You can pause the YouTube video right now if you'd like to think about this a little bit more carefully. But the answer is going to be D and E. These two are the errors. Why? Because we have a variable that is of a type that is the subclass of the thing that we're instantiating into it, right? We shouldn't put a generic person into a student variable because not all people are students. And here's a grad student variable. Well, we can't just put a generic student in there because not all students are grad students. So it doesn't work that way. Notice it works the other way just fine, right? We can make a person variable and put a student in there because students are persons. That's totally makes sense. We can stick an undergrad into a student variable because student is the superclass, so we can instantiate subclass objects into that superclass. Hopefully that makes sense. That's the rule. There's a direction there with the arrows, and this sentence does a pretty good job of summing it up. The variable's type, that's this part here, must be at the same level or higher up the tree than the object that it contains. So that's this thing here. Or this thing, actually, if I'm staying on the same line. Okay, so that's a rule to follow and to be clear about. That way you can have this kind of situation. Check this out. So this is a person array called people. So this is the very much the important reason why we want to do this. We want to do this because I would very much, if I'm making this software and I'm keeping track of all these people, there's a good chance that there's a lot of people to keep track of. And maybe this is a university, payroll / student information systems type of thing. So we need to keep track of all the people in the organization, which includes students, but also maybe guest speakers or family members, benefactors, guest musicians, all sorts of stuff. But it might also include employees. It might include all sorts of many, many different kinds of people that we need to keep track of. So if we make an array that is of the highest superclass, in this case person, we can instantiate any kind of subclass person inside of here, including just generic people as well. So that is why. Now we can keep track of all the people in one array. We don't have to make a student array and an undergrad student array and a grad student array and an employee array and a person array. We don't have to make a bunch of separate arrays for the different subclasses. We can make one array to store all the person objects and their subclasses. So then we can just keep track of all the people in one big old array. That's why. That's one of the reasons. It's not the only reason. That's a big reason why we might want to do that. That's fantastic. And the AP exam is going to focus on this quite a bit. They're going to be looking at, how these mechanisms work. And so that's going to be a big focus for the rest of this. So take a look at my sentence coming down here. So this flexibility, this ability to kind of store any kind of object, any kind of subclass object in a variable or a data structure that is of type superclass, is going to cause some ambiguous problems. These are some edge cases that are coming up. And the AP exam will focus on a lot of those things. And these problems are kind of solved by these ideas. Overriding and polymorphism are very much connected. Dynamic binding versus static binding is something we're going to talk about coming up. The super keyword will allow us to sort of get around some of the rules of these things, or maybe not get around is the right word, but it will allow us to access things that are by default not the way that polymorphism works or overriding works. So it lets us kind of have our cake and eat it too, if you will. And then downcasting is a situation that we might find ourselves getting into that's kind of confusing, and we're going to cover that pretty strongly. So I'm going to do that in the third video. So we'll take a look at all those things, and hopefully you're enjoying this and finding it clear, and I'll make our next video. Yes. Thanks, AP Scholars.